Hey everyone, Miss Barber here with lesson 1.2 in Algebra 2, Properties of Real Numbers. So a lot of these properties are things you already know, maybe you just didn't know the official name for them. So the first one is the additive identity property, which just says that if any number you take, if you add 0 to it, you're going to get that exact same number. So 3 plus 0 is going to give you 3. Any number, if we let it be n plus 0 or 0 plus n, order doesn't matter, it's going to give you that number again, n. The multiplicative identity property, so think when you add a number with 0, you're just going to get that number. For multiplication, you have to multiply that number by 1 to re-get that number. So any number, when you multiply it by 1, will give you the same answer. So 2/3 times 1 is 2/3, n times 1 or 1 times n will give you n. The additive inverse property is what number do you have to add in order to get 0? Well, for adding, it's always going to be the opposite. So 5 plus negative 5 is 0. N plus negative n is 0. So it's always the opposite, positive or negative. For the multiplicative inverse property, it's when you multiply a number by its reciprocal, it's going to give you the answer of 1, which is what you're looking for. So 8 times 1, 8 equals 1. N times 1 over n equals 1. Again, assuming n is not 0, because you can't multiply any number by 0 to get 1. I'm also going to write it like this, x over y. So if that's your number, it would have to be, you'd have to multiply it by y over x to get your answer of 1. So you're just going to flip the fraction. That's what a reciprocal means. So let's go ahead and apply this. Find the additive and multiplicative inverses. So for additive is what we'll write first. So negative 6, what do you have to add to it to get 0? Well, the opposite of negative 6 is positive 6. So that would be the additive. For the multiplicative inverse, instead of doing the opposite, you're going to take the reciprocal. Well, this is like negative 6 over 1. So flipping that fraction, it's going to be 1 over negative 6. The negative can go on top, bottom, or out in front of the fraction. It doesn't matter. How about number 2, 3 1/4? So again, the additive, you just do the opposite. Well, the opposite of positive 3 1/4 would be negative 3 1/4. So that's not bad. For the multiplicative, in order to flip this fraction, we have to have it as an improper fraction. It's impossible to flip this with the whole number out in front. So remember, to find what this is as an improper fraction, you're going to multiply the denominator times 3, what's out in front, so 4 times 3, which is 12, plus 1, which is 13. So this is the same thing as 13 over 4. So the multiplicative inverse is going to be the flipped fraction of 4/13. All right, so number 3, it's a little bit tricky for the multiplicative because it is a decimal, but go ahead, pause the video, see if you can figure it out. All right, so number 3, the additive is just going to be the opposite. It's negative, so we're going to make it positive. So it's going to be positive 0.07. For the multiplicative, again, you should have tried this on your own. It's going to be negative, again, this is like over 1, negative 1 over 0.07. Oops, my bad, I put the decimal in the wrong spot. 0.7. Well, you might be thinking, there's no way that you're allowed to have a decimal inside of a fraction, and you'd be absolutely right about thinking about that. So if you just put this in your calculator and press math, enter, enter, it would give you it as a fraction, or we know that 0.7 is 7 over 10, so flipping it, it would be 10 over 7. The negative still stays. So that's your answer for number 3. All right, so here are properties of real numbers. Again, you've probably learned these before. We don't use them a ton. A lot of them we just know to be true. So the closure property says that if you take 2 real numbers and add them or multiply them, you're still going to get a real number. So things we've taken for granted. The commutative property is that you can add or multiply numbers in any order and you'll still get the same answer. So you know that 7 plus 11 is the same as 11 plus 7. 7 times 11 is the same thing as 11 times 7. That's the commutative. You can change the order without changing your answer for multiplication and addition. The associative property uses these parentheses. So it just says you can group the parentheses for an all addition problem or an all multiplication problem, and it's not going to change the answer. And then finally, the distributive property, you probably use this a lot with solving equations. It's when there's a number out in front of parentheses with the thing in parentheses being added, you distribute the number out in front, so in this case it would be 5, using multiplication to both things on the inside. It could also be written after the parentheses. It's not often seen that way, but it works the same. You could do 5 times 2, 5 times 8. So just using algebra, it would do A times B plus A times C. So that's the distributive property. You're distributing it across the parentheses. So example 2, identify the properties of the real numbers. So which of these properties are we seeing? Number 4, hopefully you see right away that that's the distributive property. I'm taking these parentheses and I'm distributing the x to the A and to the B. So this is the distributive property. Now, number 5, let's look. I see that parentheses are being potentially moved, but I do notice that the parentheses are both n plus 6. So it's not that the parentheses moved around numbers, it's just that the numbers moved out of order. Well, changing up the order, if you remember, not carrying the order, that's the commutative property. And this is addition, so it would be the commutative, I'm just going to abbreviate it, of addition. That's addition. All right, number 6. This time, if you look at your parentheses, what's around the parentheses isn't the same. It's GH in the first one and 4G in the second one. So this is the associative, because the parentheses, what they're around changes. And this is of multiplication. These are multiplication problems. Pause the video, try number 7. We've already seen an example like this, and check your work against the key on the school webpage. All right, number 3, using properties of real numbers. So using mental math. So there's a lot of different ways you can do these problems. You don't have to do them the same way I am, but I'm going to give you how I would do number 8, and then you can choose a method for using number 9. So if I needed to find out what 5% of 150 is, and I didn't have a cell phone, I could easily think to myself, well, I know 10% of 150 is 15, because moving the decimal 1 to the left will give you 10%. Well, 5% is half of 10%. You would be dividing by 2 here, so I'm going to divide by 2. 15 divided by 2 is 7.5. So I know it would be $7.50. So again, that's just one way to think about it. You're more than welcome to think about it in other ways. Pause the video and try number 9. Is there a mental math way you can find the cost of 8 items? Again, you might not do it the way I do it, and that's perfectly fine, as long as you're getting to the correct answer at the end. All right, numbers 10 and 11. Classify each statement as sometimes, always, or never true. Give examples or properties to show your answer. D plus negative D is equal to 0. Well, that's our property. That's just our additive inverse property. So because that's a property, I know it's always true. So that's always, and that's additive inverse. Number 11. So think about number 11. Look at it. You might be thinking, it doesn't actually look like any of the properties we've learned. And it's because it's not. Now that doesn't necessarily mean, so because it's not a property, it's definitely not always true. But you're not sure if it's sometimes or never. So go ahead and substitute in values. So let A equal a number. So you can let A equal something, B equal something, C equal something. See if you can find out a way for it to become a true statement or not. So again, pause the video, try this one on your own, and then check your answer with the key. All right, last examples here, exercises 12 through 14. Write an expression to represent each total cost and then simplify it. So for number 12, the total cost of 2 pens, so I'm going to do 2 times whatever the pen cost is, which is $2.89. So I'm going to do 2 times $2.89 plus the cost of 3 notebooks. So it's going to be 3 times whatever the cost of notebooks are, which is $1.79. So multiplying and adding those together, this is going to cost me $11.15. Pause the video, try number 13 on your own. Very similar. All right, and then number 14, our last one here. The cost of 3 notebooks at a 20% discount, a binder at a 25% discount, and 2 pens. So this has got a lot going on here. So let's just start with the first part. 3 notebooks at a 20% discount. So I know I'm going to do 3 notebooks times the cost of a notebook, which is $1.79. But I'm getting it at a 20% discount. Okay, well, if I'm getting 20% off, you need to think to yourself, how much am I actually paying? If I'm getting 20 off, I'm actually paying 80% of it. Well, 80% as a decimal is 0.8. So if I multiply 0.8 by 1.79, that'll give me the cost of the notebook, 1 notebook, at the 20% discount, and I'm going to be multiplying that by 3. Now for the next part, I have to add that to a binder, so just 1 binder, a single binder, which is $3.19 at a 25% discount. So again, if I am getting 25% off, how much am I actually paying? Well, if I get 25 off, I'm actually paying 75%, which is 0.75. I'm just going to put those in parentheses. They go together. I have to multiply them before I add. Order of operations would tell me I do that anyway. And then lastly, I'm going to add 2 pens. The pens are not at any discount, so nothing to do there. So that is my expression. It's a little bit long and cumbersome, but you could put it in the calculator, no problem, and should get your answer of $12.46. That's lesson 1.2.